The first step in implementing the Quarry Vision strategic optimization system is to map the process. This begins by verifying the process layout to depict where material comes in, and where it goes out, and how it flows within the processing system. To begin, stockpiles are located to enable us to identify the most practical location for belt scales that will measure output from critical locations within the production process. Next, we identify key equipment within the system. Typically this includes crushers, screens, feeders and key conveyors within each processing segment. We also need to understand the plant layout to enable us to appropriately reference and evaluate key conveyors which could potentially limit the material flow. With that information, we create, or validate, if one is already created, a process flow model indicating type, size and location of equipment, along with process flow and equipment configuration options that could affect plant capacity and key product yield. We then begin to manipulate the flow models to represent commonly used and potential operating configurations or modes. Generally, modes are configured to drive for various combinations of coarse products or fine products as required to achieve projected sales. If necessary to verify the reasonableness of the flow models, we may take material samples from within the processing system. This is normally done by belt sampling of material at critical points within the system, starting with crusher output. Sieve testing for gradation is done to evaluate crusher performance, and apparent closed side setting, and to compare sample results to manufacturer-provided data from within the flow model. This interrupts the production process and can be a bit intrusive. So where accessibility allows, we utilize an alternative sampling option to evaluate crusher output, using digital imaging to estimate gradation from output belt photographs. This gives us the potential to effectively acquire output top-size data, and estimate the apparent closed side setting, without shutting down the process. Substituting crusher information within the flow model improves ability to project likely yields and production rate capability in various modes, providing site-customized theoretical performance projections for each segment of the production system. We take this information into account when we put the scales in, and develop the site-customized representation of process flow options. Multiple display options are available, including target and range indication for each scale. Various chart display formats are available for display of current day and historical trends and variability. Too much data can be overwhelming and confusing, so display detail should be limited to include only results intuitively meaningful and useful to the intended user. All of this having been established, setting valid performance targets then comes down to ensuring that the plant can be reliably fed at rates determined to be capable, within its various operating modes. This requires assessment of pit capacity and surge pile management practices, including evaluating both load haul rate consistency, and potential feed gradation segregation if surge pile drawdown has potential to become a crusher capacity factor. With this information, we can now accurately establish valid process rate and yield capabilities, and begin to look for process bottlenecks that can be relieved to improve results. You should expect to see potential reduction of between 10 and 20% in scheduled hours required to achieve forecast sales, resulting in likely variable cost, working capital reduction potential in most operations, simply by identifying and effectively utilizing the realistic capabilities and potential of your existing processing systems.